Okay, so for today we will look at the polar curves. Okay, we will specifically focus on the sketching part. So we will look at different types of the question and how do we deal with like the different types of the function and how do we sketch them. Okay, so we won't go through like other things which is like all about the differentiation and all about the area. Okay, so let's look at the different questions here. Right. So for the first question here. Okay, so you see this question here is a usual polar curve, okay, that we have been seeing like all the time. So this is r is equals to a times 1 plus sine theta. So we can actually draw a sketch of C. So of course, this is not something that we are not not unfamiliar. Okay, so we're actually quite familiar to this already. Of course, some tips that we can actually like sketch this kind of the curve is that for a polar equation that has like these trigo functions, okay, we could always like look at the behavior of the R first. So we could, okay, for this one, okay, we could sketch the graph which is like R against theta first, okay, like what we do in our usual trigo graph, okay. So we know that this is the behavior of the R. So we have got like, this is a pi, this is a 2 pi, and so on. Okay, and of course the values that we have here is like a and a 2a. So we know how the R goes as the theta goes. So for the sketching for the graph here, so we know that okay, when the theta equals to 0, which is the initial line here, okay, the R is an a, and then we have got like when the theta is a pi over 2, so we have got like the 2a here. And later on, when you actually go to the pi, it will become like the R is an a again. So this is actually like a negative a. And for the 3 pi over 2, it will be like a 0. Okay. And so for this, we're actually quite familiar. So this is like a cardioid. Okay, the shape is a cardioid here. So this would be the graph that we get. And let's just look at the 2 marks, okay, how it's actually 2 marks is actually given here. So from the mark scheme here, okay, we can see the first mark is given when we have got a closed curve that passes through all these points here. So these 4 are the polar coordinates, okay. So as long as the point that you pass through is correct, then you get the first mark here. And then the second one is a completely correct shape for the cardioid. So as long as they see something that is like a cardioid, then it actually gives us the mark here already. Okay, so usually for this kind of the question, it's not like very difficult for us to do, right? So if we look at like the other examples here, right? Okay, this is the other example that we have got. Okay, so we skip the first part that they actually ask us to show the polar equation. Okay, and in the second one here is we want to draw the sketch. Okay, this is from negative pi to the pi there. So what we have for this R square against a theta function here, okay, is if you want to sketch for the R square curve, okay, of course we want to see like what is the behavior of the cos 2 theta. So for the cos 2 theta, we know that the behavior of that is like, okay, this is within a pi. This is like within negative pi to pi, okay? This is the behavior of that. So we can sketch the R squared against theta graph first. So this value will be a squared. This value would be the negative a squared like that. So it helps us in seeing like the behavior of the R squared value. So because when we actually sketch the what is that, the Cartesian graph, right? Okay, for the polar here. So we need to look at the value of the R. And for this thing, okay, we want to take the square roots of all the values of the R square here. So you can actually use the idea from the y squared is equals to fx curve, like what you learned in the rational functions there, that you can actually consider like, you can draw the R against theta curve. Okay, so this is for us, I mean, to see the behavior of the R against the theta. And we know that all the values here, like this is 3 pi over 4, and this is like a pi over 4, and it will be symmetrical about the negative side of the theta there. So with that, right, okay, when we actually take the square roots of these values, so something like this, supposingly, okay, So supposingly, when we take the square roots of the values, okay, we will have the positive and the negative of the R there. But in our syllabus here, right, we need to always ignore, okay, whatever which is not like positive for the R. Okay, so when we actually consider the graph of the R against theta, that is only the part that we have got this one here. And of course, it is symmetrical about another side there for the negative theta. Okay, so ignore whatever that is like for R, which is a negative value there. Okay, so for this okay graph, we can actually like try to actually like sketch it here. So when we sketch, right, okay, there are some things okay that could help us quite a bit. If you look at the behavior for like okay this part here, so from like 0 to pi over 4 for the theta, right, the R goes from A to 0. So we know that there is okay the R equals to 0 when the theta is equals to pi over 4. So with that, right, we can actually mark the pi over 4 to actually help us. Okay, so it reminds us that okay, we shouldn't go beyond that. Okay, the R should already goes to 0 when the theta equals to pi over 4 here. So okay, we will start from the theta equals to 0. So the R here is an A, and we know that okay, especially go to the pi over 4, it should be goes to the 0 for the R there. So this is the how our graph will look like. Okay, and some more we have got like okay, the next pi which is from 3 pi over 4 to the pi there. So this is 3 pi over 4 to the pi. So 3 pi over 4 is a 0. When it goes to the pi, it will be a A also. So we will have the graph which is like this. So it should be symmetrical, okay, to the part that we have the graph that we have actually drawn just now. And if we consider the negative part of the data there, right, everything is symmetrical. So basically, we just have to do the same thing, okay, for this side here. Okay, so we can actually just like copy whatever that we have done in the previous part there. So it actually gives us the graph, which is a lemniscate. This is called a lemniscate, okay, for this graph here. Okay. All right. So that would be the graph, okay, and then let's look at the requirement from the mark scheme there. So in the mark scheme, okay, in the at the bottom right here, you can see the part okay that I get from the mark scheme here. So 1 mark for each loop or half of the whole curve. So basically, once we actually complete like one loop correctly, okay, within the range of like a negative pi over 4 to pi over 4, it will already give us 1 mark. So basically, that one loop gives us 1 mark there. So this will be like a total of the 2 marks. Okay. So usually for the sketching for this kind of the equation, right, that would be very straightforward because these are the functions that we're actually very familiar with already. Okay, and the requirement is actually not too much one. So okay, if you look at like the graph here, it's the same thing. So R is equals to negative 2a sine 2 theta. So here's the thing. So when we look at the theta, right, is from 0 to 2 pi, right? So from 0 to 2 pi, okay, let's look at what is the behavior for the sine 2 theta with a negative 2a. So for the sine 2 theta with a negative 2a, so this is the behavior for the graph. Okay, sorry, I have to extend a little bit here. So we have to like this. So this is 2a, this is a negative 2a for the graph here. Okay, right? So remember, okay, in our syllabus, we always only look at the positive R values. Okay, so let's just mark those points here first, yeah, in order for us to sketch it later. Okay, so you see, we focus on the positive part of the R first. Okay, we focus on the positive part of the R here first. So we actually do the sketching from there, right? We know that we have got some loops there. Okay, so what happened to the loops here is that, okay, from pi over 2 to the pi, there is a loop, which is like, okay, you can see the R goes from 0 to the 2a to the 0 for this case here. So this is in the second quadrant because it's from pi over 2 to the pi there. So there's a loop in the second quadrant there. Okay, so that is for the second quadrant. And for the last quadrant, from 3 pi over 2 to the 2 pi here, our r goes from 0 to 2a to the 0. So that is where we actually have got another loop here to make sure it's symmetrical. Okay, about like this line here. Okay, so it looks like that. So this is what we have, okay, for the case that if we have like the positive r. So if you look at the here, it's very important that we look at the mark scheme here. Yeah, the mark scheme here says that the first B1, okay, is when we have got the loops in the second and the fourth quadrant. Okay, so the mark scheme is actually not that detailed. Okay, we are not sure that, okay, when we sketch the negative value of the r there, are they going to like deduct our marks there? We are not sure. Okay, although some of us might actually learn already, okay, how to actually deal with the graph when we have got the negative r there. So if you actually include this part, right, in our graph, right, it will actually become a flower that has 4 petals. This is a part that if you actually include like the negative r there. Okay, but we do not know what is the requirement of the mark scheme that we see is not so detailed. Okay, we are not sure whether if we include this green part here, they will deduct our marks or not. So the best thing for us to, to do is that whenever we see negative r, we will just ignore. Okay, so that is something like that we can actually look into it. Okay, so that would be like the B1. Okay, B1 is actually when we draw the orange curve. Okay, there will be 1 mark, and then another one is symmetry and also the shape correct. So it will be a loop, and also it must be symmetrical about the line, which is y is equals to x. Okay, then we can actually get the marks for this one here already. Right. So that's if you look at like okay, the following part of the question here deals with a little bit about the trigo, okay, but the trigo are not those like sine and a cos. Okay, this is like an a tangent theta. So in the event or in the question that we see like if the first part of the graph they already do the sketching, so usually it's the case that the graph is something that we are familiar with, like all the functions that we have seen earlier, or it could be something that is very simple to sketch. So the simple that we have here might be like a monotonous R. So if you look at the function of the tangent theta here, right? The theta here is only going from like 0 to 1 over 4 pi. And we know that for a tangent function, when the theta is in between 0 to 1 over 4 pi, the R is always increasing. Okay, the R is always increasing here as the theta is increasing. So how do we actually do the sketching here is very easy, in fact. So if I've got the function here, okay, we could, okay, like try to sub the values in a little bit. So when R equals to 0, sorry, the theta is a 0, then we have the R equals to 0. Theta is 1 over 4 pi. The R is 1. So we know that the graph is actually always increasing. So the R is actually going from 0 to a 1, right? So we can actually do the sketching very easily, right? So the graph that we're actually going to sketch here is, if there is an important value of the theta, so always include that, because we know that the theta is only up until the 1 over 4 pi. It is good for us to include that, so that it reminds us that, okay, we shouldn't go beyond that, okay, for the theta here. So, okay, very easy. It's about like the R is actually getting larger and larger. When the theta is a 0, the R is a 0, we know it will start from the pole or the origin. So the R will just get larger and larger. So this will be the graph that we actually have. Okay, so just make sure that the R is getting larger and larger up until the theta is equals to 1 over 4 pi. Okay, so let's look at the maxim here. Okay, yeah, so this is what the maxim is actually looking for. If you look at the question, there are 2 marks. 1 mark is for the sketching, and another mark is for the greatest distance. So basically, the sketching here shouldn't be something that is very complicated. Okay, so I guess, okay, the criteria here is that as long as they see we have got this kind of the curve, then they will like give the marks already. Okay, so it's very straightforward for this question here. Right. So we will look at the like the other questions here, okay, which might need which we might actually need to give more attention to that. Like for example, this question, which is a reason question. Okay, so we have got the polar equation, which is like, okay, we have got the r squared is an arctangent of a half theta. So here the theta is going from 0 to 2. And we can see that in the very first part of the question, they already asked us to sketch it. Okay, so if you look at the question here, right, sketching and also state the greatest distance. So we need to expect that the sketching here has got 2 marks. Stating here has got 1 mark to that. All right. So from here, okay, if you look at the function, so the function here is that r squared is equal to arctangent of the half theta there. We need to be familiar with like different types of the functions here. This is an arctangent. For the arctangent here, right? Okay, it's actually an increasing function. Okay, because when we look at the theta, so when the theta goes from 0 to 2, okay, it's an increasing function for like the arctangent here. Okay, I mean, like even like if we are really not sure, okay, what happened to the function here, right? We could always sub in some middle values, okay, from 0 to 2 here for the theta to check, okay, whether are the like the r is always increasing or the r is actually always decreasing here. Okay, so in this case, the r square value is always increasing. So we will expect that the r gets larger and larger. Okay, and for that, right, we can actually do a bit of the substitution. So where the theta is a 0, okay, the r value when we sum in, right, it gives us a 0. And where the theta is a 2, and here the r here is giving us a pi over 4. So we know that the r is actually going from 0 to the pi over 4. Okay, from 0 to the 2 for the theta there. So as we do the sketching, so draw a line to indicate that the theta is a 2. So theta equals to 2 is somewhere in the second quadrant. Okay, if you want to be more precise, you can change that to the degree to see, okay, roughly what is the angle for that. But they are not really looking at that detail. So as long as we have got like the theta equals to 2, which is marked here to, you know, like to remind us not to go over that theta. Okay, and as we are trying to doing the sketching here, so we know that when we have got the theta equals to 0, the r equals to 0. So the graph actually starts from the origin and it will just get larger and larger, okay, for the r here. So the graph that we can actually draw, it could be something like from here, it's getting larger and larger, and then you actually go to the r is equals to 2 there. Okay, let me just draw a nicer one. Okay, wait, just draw a nicer one. Okay, I'll just extend my line here, yeah. So okay, so this is the graph that we can actually have. Okay, so the mark scheme. Okay, if you look at what we have for the mark scheme here, okay, is that 1 mark is given when we have got the correct domain and the r is strictly increasing. So we just have to sketch our graph from 0 to the 2 for the theta. So if you have got anything which is more than that or less than that, we won't get the marks from there already. So it's important for us to actually mark this here. Okay. And after that is the correct gradient when the theta equals to the 0 and the theta is equals to 2. So this is the details that they're actually quite like looking for. So what do they mean by the correct gradient here? Okay, the correct gradient here is actually referring to the things which is like, so when we do the sketching, right, there are some values, important values that we need to look for, which is like when we have got the origin. So whenever we want to like sketch the graph, which is at the r is equals to 0, right, there is one thing that particularly we want to look for. Because we know that when the r is equals to 0, right, okay, it can actually gives us a tangent line. Okay, so when the r is equals to 0, okay, let's see what is the situation. If we have got the r is equals to 0, okay, the theta equals to 0, right? This means that this theta equals to 0 here is a tangent line. Okay, because we know that to find the tangent line at the like this origin here, right? We will let the r equals to 0. Okay, and then we find what is the value of the theta. Okay, from there we find what is the value of the theta here. So this value of the theta is a tangent line to the curve. Okay, it's a tangent line to the curve. In the drawing that I actually have done just now, right? It doesn't really look like a tangent line. Okay, so you can see the difference here. So I show you like the difference of what I actually sketch here with the one that is in the mark scheme. Yeah. If what I did here, okay, is like in the sketching, they will have, you can see the graph doesn't really like it's not really close to the this thing here, the x-axis here. Rather, it actually starts like quite far away from the x-axis. So in case like in a case like this, right? Because we say that, okay, when the r is equals to 0, we get the theta is a 0. Theta equals to 0, it should be a tangent line. Okay, when theta equals to 0, it should be a tangent line. So when we see the graph here, right? Yeah, this is a y-axis. So you can see the graph here, right? It is really like really close to the theta equals to 0, then only it will actually start turning. Okay, so this would be like the details that we need to actually pay attention to. So the graph shouldn't look like that, although the r is always increasing. When we have got the theta equals to 0, it should actually forms like a sort of like a tangent line to the curve there. Okay, so it's something that we could actually like pay attention to in order for us to like score like the marks. Okay, 1 mark there at least. Okay, so always pay attention to the situation where the point, okay, when like the r is equals to 0. Okay, this is the thing that is worth to pay attention to. Okay, we have like other examples which is related to all this thing later. Okay, but okay, let's look at the other graph here. So this is the graph, okay, that is having this polar equation. R is 2 cos theta times 1 plus sine theta, okay, and then the theta is from 0 to half pi. So in the first part of the question, it's a 5 marks question that they already asked us about this, okay, so you can refer to the answer there, and you can actually do the sketching for that. So for the questions, right, if before the sketching, okay, they have already asked us quite a bit of the question, it means that all the questions that they have asked before the sketching is helpful for us. Okay, so it means that, okay, in our sketching, we should show those features, right? It should help us, I mean, we should show the features that. The feature that we have here is, at this point, okay, it should be furthest from the pole, or this is actually our maximum R here lah. Okay, so as we do the sketching, right, okay, we will see that we've got like the theta is from 0 to half pi, which is in the first quadrant. Okay, and also like we can see the function here is not so straightforward. So we can expect that it is not really like a strictly increasing R or a strictly decreasing R. So that's why the part A is here to help us. And okay, another thing is, okay, let's say when we actually try to sub in like the values for like the theta 0. So the R here is when the theta equals to 0 here, we have got the R is a 2. Okay, and then when the theta equals to half pi here, the R is a 0. So from there, right, okay, what we actually can look at is that when we sketch the graph, okay, so we know that, okay, when the theta equals to 0, the R is actually giving us a 2. But as it actually goes to the half pi there, right, the R should actually goes to the origin. So we sort of expect that, okay, it will be a curve which looks like something like this. Okay, something like this. But there are some features that we need to show from there, yeah, including where the maximum R happens. Okay, it is happening around the pi over 6. So the pi over 6 is around here. We don't need to really show that line, okay, for the theta equals to pi over 6 there. But just make sure that we have got a point which is like furthest from the pole. Okay, so when we actually sketch that, Okay, we will have, okay, the graph that can actually look like this. Something like that. Okay, my drawing here is not so nice. Yeah, so you draw a smoother curve like that. Okay, not so smooth there, but okay, yeah, it's okay. So it's something that we can actually see from there where we have shown the feature. So let's say this is a point where we have got like the pi over 6, right? Which you don't need to really mark it in your diagram. But here we have already shown that it is actually indeed like furthest from the origin. That's one thing that we want to feature for that. And another thing that is also worth to look at, yeah, is whenever we have got the r is equals to 0. So this point is like really important. Okay, whenever we have got the r is equals to 0, it actually happens at the theta equals to half pi. So in my sketching here, right, it might not be a really good curve, okay? Because, okay, when the theta is equals to a half pi there, it should be a tangent to the curve. So when we actually sketch this curve here, right, it doesn't really look like a tangent, okay? The theta equals to pi over 2 here doesn't really look like a tangent line. So that's something that we have to pay attention to because it's actually considered in the mark scheme. Okay, you can see the allocation of the marks there, yeah. So the B1, the first B1 here actually consists of a lot of the criteria, okay, that we need to fulfill. Then only we can get this mark here. Shape, yes, okay, from what I actually sketched here, right, is correct already. And strictly increasing to pi over 6, then strictly decreasing, yeah, okay, it's sort of there. But the feature, okay, that I mean, this characteristic that we need to show here, tangential to theta is equals to pi over 2 at the pole. So in in my sketch just now, it's not something that is quite obvious, okay? When we sketch it, you can see like, of course, this is what they use, like they use a plotter, okay? So this is when we have got like the theta equals to pi over 2 there. So really show that when it is near the pi over 2, it is really tangential to the curve there. So what we can improve on this curve here is that, okay, we can actually draw it much closer to the theta equals to pi over 2 when it's actually go like near to the pi over 2 there. Okay, so this is more like a getting closer and closer to the pi over 2 for the line there. Okay, so yeah, something that is worth for us to look at. Okay. So I mean, it's better for us to actually do like this because we are not sure how straight, okay, or how lenient the examiners will be. Again, it also depends on every year. Okay, so better we just do it like perfectly. Okay, then we can guarantee that we actually get the 1 mark here. Okay, so for the another mark here is something that is quite easy for us to obtain, which is the graph is in the correct position and all in the first quadrant. So the second mark here should be something that is quite easy for us to obtain from that. Okay, something that is worth for us to look into it. Yeah. All right. For the okay, for the other questions that we have here, right? This one. It is to sketch the sea. So they are mainly like two types of the question. One is like in the very beginning, they already asked us to do the sketching. So if usually this is the case, then the R should be strictly increasing or decreasing. Okay, that should be very obvious for them. If you look at the function here, this is a negative e power negative theta. Okay, so for the negative of the e power negative theta, right? So we just have to see whether is this like strictly increasing or strictly decreasing. So in this case, it is actually a strictly increasing for the R here. Okay, it's a negative, and then the exponent is with the negative power some more, right? So this would be a strictly increasing graph. So with this, okay, we can actually have like find out what is the value for the theta is a 0. So when the theta equals to 0, the r is a 0. Theta equals to 2 pi. So we have like the r is taking that exact value, 1 minus e power negative 2 pi. But again, we know that it's strictly increasing. Okay. So for this, okay, they actually allocated 3 marks, okay, which is quite a lot in the sketching. So we have to pay more attention to like this sketching here. Okay. So the sketch here consists of like all the 4 quadrants. Okay, and then we know that, okay, when the theta equals to 0, the I equals to 0, so it is actually starting at the origin. And we will just expect that the R gets larger and larger. Okay, it gets larger and larger. So we can expect something that is like the spiral, okay, that you see in like your golden ratio, that kind of the spiral. Okay, so yeah, we can actually draw the spiral, which we just have to show that the R is getting larger and larger. Okay, that's the graph that we will actually get. It's almost there already, okay, but always, okay, the thing that we always want to pay attention to is always about the tangential property, because again, when we have got the theta equals to 0, the r is a 0. This is the point that we need to pay attention to when we actually sketch, because we are supposed to show at the theta equals to 0, okay, it should be tangential. So tangential means when we start the graph, right, we shouldn't start like so sharp here, okay? You can actually like try to like, okay, let me just zoom in a little bit. This part of the graph, right, you can actually try to make it more closer to the theta equals to 0 first, then only you start to do the turning. Okay, so for a better version of it, okay, would be like, okay, then you continue from there. Okay, so the purple one, the starting point there is a better start. Okay, so if you look at like for this one, right, okay, is it like considered in a mark scheme here? Okay, is we can look at the mark scheme here, right? Okay, so there are some special things, okay, that we want to look at here. So the first one is approximately correct shape and the location. So I think a lot of us can actually get this mark, okay, as long as we know that when the theta equals to 0, the r is equals to 0, and then the r is actually just keep increasing, okay. Like a lot of us, I think we can actually get the marks here, okay. So after that, okay, is the second one, show initial line to be tangential to the C at the pole. So this is what we did in the purple curve, okay. And okay, the third one might be something that it's very subjective to the examiners. Okay, so asymptotic approach to the circle, which is like the r is equals to a. In a math scheme, they don't really have like the real sketch for us. I mean, you can use a plotter to actually check your answer. But for the third part here, right, where they actually ask for like the asymptotic approach to the circle, which is r is equals to a here, it means that the spiral that we have actually drawn here, right, should be like, so, okay, before we look at the graph here, so what do they mean by like the circle, which is like the r is equals to a? Why do we actually have got like that asymptotic approach? It's because that when the theta approaches infinity, the e power negative theta will actually approach a 0. So finally, the r will actually approach an a. So as the theta gets larger and larger, we will actually like the spiral will just go near and near to the circle. But for this case, right, as long as I guess, okay, because we don't have the real figure in the math scheme, but I guess as long as the when we actually like have like the towards the end, this part here, right? Okay, this part towards the end here, this part, when we actually try to sketch it like almost like a circle already, then we should be able to get the marks already. Okay, I mean, again, it depends. It's very subjective, depends on the examiner, okay, whether they want to give the marks or not, or they are lenient or they are strict. We don't know for every year. Okay, so just try to like give like details, okay, as much as we can when we actually sketch the graph there. Okay, but to be honest, the third mark here is quite difficult for us to expect. Okay, so I guess I'm not sure whether like they will be very lenient about that. Okay. All right. Okay, so there are a few more questions that we could look at, but let's just go through those very quickly because we do not have a lot of time to look at it. Okay, so this is another thing. So we have got r squared is equals to ln 1 plus theta from 0 to 2 pi. So we see this is a ln function. So we expect that the r is getting larger and larger. Okay. So the r is strictly increasing, and also like when the theta is equals to 0, the r is a 0. Okay, so I won't sketch it. Yeah, I'll just tell you roughly what happened to this case here is that when the theta equals to 0, r equals to 0. So this is where the tangent will happen. Yeah. Okay. So when the tangent is actually happening, so it means that when we actually have like the line, which is like theta equals to 0 here. So you can see this is the asymptotic, not the asymptotic, this is the tangential. Okay, the tangential approach there. So you can see like the second marks here, right? There's a specific mark that is actually like they really want to see, okay, the tangent property here. The first mark is usually we can like get it very easily, right? It's all the correct shape, and then we draw from 0 to 2 pi, and then the orientation of the graph, which is like this here. Okay, so it's usually this mark about like all the tangential stuff that is like quite difficult for us to actually get. So we really have to pay attention to this. All right. Okay. I guess we will just choose some of the questions to highlight. So for this question, we can see like when before they actually ask us to do the sketching in the part 3 here, right? They ask us to do quite a lot of things. In the part 1 is to show that, okay, as the theta increases, the r decreases. So the r is actually keep decreasing. And also in the part 2 here, right? If we have got like the point P, okay, of the C is further from the initial line than any other point of the C. So show that at this point P here, we've got this equation here, and then it has a root which is in between 1 and 1 and 1.2. Basically, what happens in the part 2 here is that, okay, it should be a maximum y. So in the part 2, right, we have already shown that around the theta, which is 1.1 and 1.2, there is a maximum y that happens. Okay, so we are supposed to like show the feature in the sketching. Okay, so let's just look at the mark scheme straight away. So you see, they want to have like, okay, this is the 2 marks, the first 2 marks here. Approximately correction and placement for the 0 to pi over 2 and passing through the A0 and this 0.4a pi over 2 approximately indicated in some way. So indicated in some way here means that they really want to see the intercept. So it's very important for us to like mark the intercept correctly. Okay, we need to really mark the intercept correctly here. So for the graph here, right? Okay, because they don't have the drawing here. So what are we supposed to do here is that, okay, we have got when the theta is a 0, it will pass through the A. And then it will just get smaller and smaller until like, okay, this is the point where we have got like a 0.4a, let's say. Okay, so we know that it's a graph that is going like this. Okay, so one important feature, remember, is the maximum point, or rather we say maximum y around this theta here. So we really have to show the feature. Okay, it's not so clear here yet. Really have to show the feature. So there is a maximum y that occurs here. Okay, this is the maximum y that we want to see here. So this is why in another mark of the question here, they are looking for that one. So the maximum y should occur around like the 1.1 and 1.2. Okay, so this is the type of the question that they ask us to find a lot of the info, then only after that we draw the sketching. So we have to use all those info that we have actually found earlier to do it, right? Okay. Let's look at okay, let's look at the this curve here. Sketch C, okay, and state the polar coordinates of the point C furthest from the pole. So we will expect that the sketching here has got 2 marks here, okay? And as we actually look at the function here, right, So usually in the first part, if it is a sketching, then it should be something that is very easy for us to sketch, which means that, okay, if you look at the theta here, so as the theta is actually increasing from 0 to pi, right, we will expect that the r is actually getting lesser and lesser. So of course, we can actually sub in some values to see. So when like theta equals to a 0, the r is a ln 1 plus pi, okay? And when the theta equals to a pi here, then we get the r is actually a ln 1, which is a 0. So again, when the theta is a pi, we will get the r is equal to 0 here. So this is the part where we have to really look at the tangent already, okay? And we just have to sketch them, okay? It is starting at the ln 1 plus pi. And as the theta is actually getting larger and larger, so you can see this particular part here, yeah, that is, we are really showing that, okay, they didn't show the y-axis here. So this is the y-axis. So this is the line where we have got like the negative x-axis. So when it actually goes to the pi, right, it is really tangential. So when they actually go to this origin here, it is not like a sharp. Okay, it's not so sharp there. It will be like getting flatter and flatter. It will actually go like almost horizontally when we go to the theta equals to pi there. Okay, this is the thing that they're actually looking for. So 2 marks, okay, one is usually given by the general shape, and then another marks here is like they are really looking at the part where we have got the tangent thingy. Okay, so when we sketch that, be very careful about that. Okay. So other than that, okay, we also have got the this kind of the function here. So again, okay, we see if there's sketching in the very beginning, the function is not something that is like usual trigo like sine and cos. If we look at like the theta, okay, which is from 0 to half pi there. So if, okay, the theta here is increasing, okay, the r here is also increasing as well. Okay, so sub in some values, okay, to see what are the values of the r there may be, right? So when we have got the theta equals to 0, the r is a 0. And then when we have got the theta is equals to pi over 2, we will get 1 over pi. Okay, so the r is getting larger and larger. The r is increasing. So when we actually sketch the graph, okay, again, like we have got this is a tangent again, right? This is a tangent. So you can see in the correct graph, right, that we're supposed to draw here is you can see in like the very beginning when it actually starts from the origin there, it should be tangential to the curve. So make sure that we don't really like start the curve which is like this. Okay, it should be really going like very close to the theta equals to 0, then only we do the turning there. Okay, some details that we can actually look at. So this is the mark that we can actually get for the last, the B1 here. Okay, other than that is like the second mark here is like the strictly increasing in the correct domain. And then the first one is given when we have like approximate correct curve. So once they see the shape which is like this already, then they will already like give us a mark there. Okay, so it's all about like all these tangential. Okay, it's very important for us to get this mark so we won't like actually miss out any marks from them. Okay. So the question after that, I guess, is nothing much for like if you look at the question, which is something like this, right? Anything, okay, the second part is the sketching. So anything comes before that is actually helping us in doing the sketching here. Okay, so this is to sketch the two curves on the same diagram after we have found the intersection. And we found out that, okay, this is actually the intersection. They are intersecting at the theta equals to 2. So from these two graph here, right, we know that when the theta is increasing, the r is also increasing as well. Okay, so we can actually just sub in some theta inside and see how the r goes there. Okay, so it is actually helping us in actually like doing the sketching here. It's actually not like a lot because this one we have got like 2 curves, right? And it's 2 marks. So one curve only have like 1 mark worth. Okay, so we actually do the sketching here, we just have to use the previous information to help us to do the sketching here, right? So other than that is, okay, we can look at this one here. So the two curves, okay, you can see there's quite a lot of like exponent functions. And they tells us that, okay, they have got an intersection point, okay, which they will intersect at this theta is equals to alpha here. So we want to show that, okay, the alpha satisfies this equation. So of course, this is like to find what is the value of the alpha, okay? And we can find the value of the alpha and show that the R value there is a forced 2. So we are using this information, okay, to sketch the second part of the curve there. So in the second part of the curve there, okay, there are quite a bit of things that we want to consider from there, okay? So here, right, okay, here, right, because the function here like e power theta and e power negative theta there, because of this kind of the function or the property there, we are not really sure about like whether the R is strictly like increasing or strictly decreasing. Okay, it's quite difficult for us to actually look at. Okay, so from there, okay, the strategy that we could use is that we can always sub in the values. So for C1, we can always sub in the values and see like the theta equals to 0. So what happened to the R there? And pi over 2, what happened to the R there? And we can sort of like guess, okay, what is the property about the C1. So in the case for the C1, so when we have got the C1, right, C1 is a red curve. So C1, when the theta equals to 0, it has got this value. When the theta equals to pi over 2, it has this value. And we can actually sketch the C1 first. Okay, we'll sketch the C1 and then it will be something which is like this. Okay, and after that, okay, the C2 is when the theta equals to a 0 here, right, the R is actually a 0. Okay, so that is why we are actually having like the C2 is actually starting from the origin. And from here, when we sum in the theta equals to half pi, right, we can find what is the value of the R here. So we compare the R values for the two curves. So for the C2, supposedly it should have a larger value of the R, okay, than the C1 there. So it should be further from the C1. And also, we have found the intersection between them, right, which is like around this radian, ln 1 plus Z2 radian. So you can actually just show that, okay, they have got the intersection here. Okay, so it's to use all the previous information to do all the sketching here. Okay, so it depends on like the mark scheme here. So the 3 marks here, right, is like 1 mark for each curve, and then they have got the intersection. Okay, so which you can see that we have the C2, right? Even we have got like this, okay, the theta equals to 0, the R is equals to 0. Supposedly we should show the tangential like property here. But when it comes to this question, they are not particular about the tangential property already. Rather, they actually focus on the intersection. So different questions has got like different requirement. Okay, sometimes they just want to look at it, sometimes they don't want. But I mean, if we could do it nicely, so we will try to put in as much detail as we can. Okay. So the other questions is actually having the similar property from there. Okay. So the things, the sketching here, like for this question here, right? We can, okay. So they actually ask us to do a lot of the things from the part A and the part B already. So basically part A, what they actually want us to find is they actually want us to find the maximum of the X. So we are expected to show the feature. Okay. And then the part B here is the intersection. So this intersection is also helping us in the sketching. Okay. Then only we do the sketching from there. So in the sketching, we are expected to show all those features there. Okay. So we have got this is the maximum X that we need to show. And then we have got the intersection that we also need to show in the graph. Okay. So if we look at the allocation of the marks in our case here, right? One for intersection. And then the 1 mark is for like the C1, another one is for the C2. So again, they are not really looking at the tangential property again. In fact, the tangential property should actually occur at this X and the Y coordinate, the Y-axis here. You can see the graph here, right? This is should be the tangent. This should be the tangent because at that 2 points, the I is actually equals to 0. So yeah, they have different requirement every time. But of course, we could sketch the graph nicely every time. Okay, in case if they're really needed. Okay. Yeah, so the rest of the question you can actually try to look at it yourself. So you have already sort of know that what is the things that they are actually looking for when we actually try to sketch the polar curves.